Hi there. So in this section, we're going to look at decomposing partial fractions, and I'm going to go ahead and start with a disclaimer. For those of you that this is your last math class, you will never find another use for decomposing partial fractions. I said it. But for those of you that plan to move on and take calculus, you will be using partial fractions. So, and especially in Calc 2, when you start taking integrals, and if you go even further in terms of taking the course differential equations, you will decompose rational expressions into partial fractions, from time to time in order to create a more a simpler problem to be able to evaluate. All right, so with that said, in this set of notes, I've kept our decomposition fairly straightforward, and we're only focusing on linear. There are other cases, but nevertheless, most likely when you got into a calculus course anyway, your instructor would need to revisit this, but it's important though that you already here in 171 have a foretaste of what it means to decompose into partial fractions, so that when you get there, you can build from there. So a rational expression, as you hopefully are very aware of by now, is of the form p of x divided by q of x. We'll be looking at scenario 1 only, and that's where the degree of the top is less than the degree of the bottom. You'll always want to factor your denominator and make sure that it's a product of linear factors like we've been talking about, and we are only going to be looking at linear factors. Then you're going to assign each of those denominators with letters up top, A, B, C, and so on. We'll only go up to 3 terms here in this set of notes. You will clear your fractions by multiplying by your least common denominator like we've done before. Then from there, you're going to choose values that will make those individual terms equal to 0 so that you'll be able to solve for A, B, and C respectively. That'll make more sense in a few moments when we actually get to a problem down here. And then, sometimes you might have to choose an additional value for x to find your a, b, or c, but you won't see that here in this set of notes. And ultimately, you'll write your final answer as a decomposed partial fraction. And all of this will make sense as we move into these examples here. Scenario 2 is what happens when the degree of the top is bigger than the degree of the bottom. You actually use long division and go from there. So like I said, I don't have that here in this set of notes. I just wanted to focus on doing linear decompositions. And that's what my note here says. We're just going to focus on linear, and we'll not expand to that second scenario. So here I've got 4 examples. I'm going to do example 1 and example 3 with you, okay? That way you can try example 2 and 4 on your own and make sure you're tracking. So here in example 1, we've started here with a rational expression, and you notice here that I'm already, everything is already factored out. So I am actually ready to go ahead and write this as a decomposed piece, where I said a minute ago that you're going to use A's and B's, and what you do is that you put A over the first element in the denominator, which is x minus 3, plus B over the second element in the denominator, which is x plus 2. If there was another item, then I'd have plus C over whatever that item was. But since I don't, then that's as far as we'll go. You'll see that in the next example that I work with you. So what I'm trying to do now is I'm trying to figure out what are the A and B terms that decompose this given rational expression into these 2 pieces here, okay? And ultimately at the end, once we find our A and B, if we were to add these 2 pieces here together, we would get this, okay? So they are one and the same, they're equal. You are just breaking it down as just something simpler, okay? All right, so now from here, your next step told you to multiply by the common denominator. So like we did in a prior section, multiplying by your least common denominator, well, we can see here that my common denominator would have to be just these denominators, x minus 3 times x plus 2. So when we multiply the left-hand side by our common denominator, the whole denominator goes away, and I'm just left with x plus 7 equals. When I multiply a times my common denominator, then the x minus 3's cancel out, and I'm left with a times x plus 2. Plus, when I multiply the last term, the x plus 2's are going to cancel out, and I'm going to have b times x minus 3. This is the form that we're going to be using to solve from here on. Okay, so this is the form that you want to keep your eye on. All right, so now from here it said to choose values that would let particular terms equal 0. So what we meant by that is you want to focus, we're trying to solve for A and B. You want to focus on these parentheses here beside the A and beside the B, such that if you were to put a value in one of those parentheses, that it would make it equal to 0. So for example, if we focus on the A, if I were, what could I let x equal in that right beside the A? What could I let this x equal so that this parenthesis turned into a 0? And hopefully you would agree that I could let x equal -2. So that's exactly what we want to do. We want to let x equal -2. And by doing that, I'm going to this form that I've just started here, and this is what we're going to use. Everywhere we see an x, we're going to plug in -2. So I have -2 plus 7 equals a times -2 plus 2 plus b times -2 minus 3. All right, keep going. On the left-hand side, 7 minus 2, of course, that's 5. A, parentheses, well, we know that turns into 0, plus b times, oh, that turns into -5. So then the a times 0 is just gone, so I have 5 equals, agree with -5b, right? Because a times 0 is just 0, so that's going away. -5 times b, -5b. Now to get b all by itself, divide both sides by -5. So b equals -1. So we found our b, okay? So now we need to focus on, okay, we need to find our a. So now we need to ask ourselves this second parenthesis, what do I let x equal here so that this parenthesis will turn into a 0? And hopefully you agree. If I let x equal a +3. Go back to this starred form. Everywhere you see an x, you're going to plug in 3. So I have 3 plus 7 equals a parentheses 3 plus 2 plus b parentheses 3 minus 3. Just keep going. 3 plus 7, of course, is 10. A times 5 plus b times 0. So the b goes away. So now I'm left with 10 equals 5a. Divide both sides by 5. So a equals +2. So now your final answer is to go back here at the very beginning where we had these pieces right here and replace your a and your b so that you have, I'm going to write the original problem that you had there. You had x plus 7 over x minus 3 times x plus 2. That equals a we just found was 2 over x minus 3, plus b we found out was -1 over x plus 2. Now technically, if you wanted to replace, technically right here I have a double sign, but I just wanted to emphasize that our b was -1. You could write 2 over x minus 3 minus 1 over, so like, let me go ahead and just show it. We could say that this is the same as 2 over x minus 3 minus 1 over x plus 2, okay? Either way is fine, okay? But my point here is, now if you were to kind of undo all of this, if you were to go through and try to add these two fractions together, you would find that it equaled that one. And so this is the final answer here. You have taken this rational equation here that you were given and now decomposed it into two partial fractions. And like I said, that will be beneficial to you folks moving on to calculus and whenever you start taking integrals, okay? And more especially in Calc 2, and then moving into differential equations. All right, so I'm going to let you try example 2 because example 2 runs exactly like this one. So you can try your hand at that, and I've shown all my work on the solution key. And then I'm going to flip it over, and let's look at example 3 together. So you'll notice here in example 3, one big difference here on the, it is a little bit more involved, but on the bottom you'll notice that it's not fully factored. So that would be the first thing that I'd want to do, is I'd want to come through here up top, or on the bottom, excuse me, and let's factor that x squared minus 4. Right? I can make that x plus 2, x minus 2, the difference of squares, and then I have my x plus 1 at the end. And the top stays the same, so you have 3x squared minus 11x minus 26. Now I can start breaking this up because I have my all linear factors now, so I can say, okay, well, this equals a over the first piece of the denominator, x plus 2, plus b over the second piece, x minus 2, plus c over the last piece, x plus 1. Okay. Now from here, just like you'll notice I'm doing the exact same steps, it's just a more involved problem, okay? From here, your next step, get rid of the fraction, so you multiply by your common denominator, and so that common denominator will just be those three pieces in the denominator, x plus 2, minus 2, and x plus 1. So when you multiply the left-hand side here, the whole denominator goes away, and you're left with 3x squared minus 11x minus 26. The next term, the x plus 2 is going to go away, and you're going to be left with a times the other two pieces, x minus 2, x plus 1. Next term, you have b. The x minus 2's are going to go away, and you're going to be left with x plus 2, x plus 1. And then lastly, c times the x plus 1 is going to go away, so you're going to have x plus 2, x minus 2 left over. Okay? This is the form now that you're working with. And we've got to, now in this case, solve for A, B, and C. All right, so there's just three pieces to solve for. We want to, again, target values that are going to make these parentheses on the right-hand side equal to 0. So if we tackle this first parenthesis that you see here, what value could I put in for x in that first parenthesis to make this term right here equal 0? And let me star this one again. This is the one we're going to be referring to the whole time. Hopefully you agree that I could let x equal a positive 2. So that's what you want to do. Everywhere you see an x now in that equation there, I want to put in a positive 2. So I have 3 parentheses 2 squared minus 11 times 2 minus 26 equals a, second parenthesis, 2 minus 2, 2 plus 1, plus b. Everywhere I see an x, I'm plugging in 2. So 2 plus 2, 2 plus 1, plus c, parentheses, 2 plus 2, 2 minus 2. All right, so now let's go from here. Let's just start cleaning this up. So from here, we know that 2 squared is 4. 4 times 3 be 12. 11 times 2, minus 22, minus 26. All right, I'm just going to go through and I'll just evaluate these parentheses. So that first parenthesis, 2 minus 2, that's going to give me 0. 2 plus 1 will be 3. Plus b, 2 plus 2 is 4. 2 plus 1 is 3. Plus c, 2 plus 2 is 4. 2 minus 2 is 0. Clean up that left-hand side. So your 12 minus 22 minus 26 should give you negative 36. Notice how your A has a 0 in it, and all that's multiplication, so 0 times anything is going to go away, so the A is going to go away, and notice your C is going to go away because it has a 0 being multiplied, so the C will go away as well. You're left with then 4 times 3, which is 12b. To get b all by itself, divide by 12. So now we've found out that b equals negative 3. So we've got our b value. All right, now let's go move to the next parenthesis. In the next parenthesis, what could I let x equal here so that this parenthesis would turn into a 0? I would let x equal, hopefully you agree, negative 1. So I repeat the same process. 3 times parentheses negative 1 squared minus 11 times negative 1 minus 26 equals, I'm just going back to this top piece here that I've, let me highlight it for you. Maybe that'll help too. This is the one that I'm focusing on. Okay. To my pen. Okay. A parentheses. I'm plugging in a negative 1. So I have negative 1 minus 2, parenthesis negative 1 plus 1, plus b, negative 1 plus 2, negative 1 plus 1, plus c, parentheses negative 1 plus 2, negative 1 minus 2. All right, let's start cleaning up. So on the left-hand side here, negative 1 squared gives you a positive 1. So that's 3 times positive 1, so that's just going to give me 3. Next term, negative times negative gives me positive 11 minus 26 equals a. First parenthesis will give me negative 3. Next parenthesis will give me a 0. plus b, that's going to give me a positive 1 in the first parenthesis and then a 0 in the second, plus c, positive 1 and negative 3. All right, we just keep going. Oh, looks like I'm going to run out of room. Let's see, if I clean up here, I should get negative 12, 14, yeah, negative 12 equals, hopefully you agree, the a and the b this time are going to go away because they have zeros in them, and I'm going to be left with negative 3c divided by negative 3. So c equals, what's that, positive 4? So now we have our c value. Last time, all right, so we've let x equal positive 2 and negative 1. So if I move to my next term over here, if I move to this term right here with my b, what could I let this term equal so that this equals 0? We would need to let x equal negative 2. I'm just going to come down here, let x equal negative 2. So if you let x equal negative 2, then you have 3 parentheses negative 2 squared minus 11 times negative 2 minus 26 equals a times negative 2 minus 2, negative 2 plus 1, plus b, negative 2 plus 2, negative 2 plus 1, plus c, negative 2 plus 2, negative 2 minus 2. Okay, start to clean up. So I have 3, that negative 2 squared gives me a positive 4, so that really lands me at 12. Negative times a negative will give me a positive 22 minus 26. Let's see, then I would end up with a, first parenthesis is going to be negative 4. Next parenthesis would be negative 1 plus b, that's going to give me a 0 and a negative 1, plus c is going to give me a 0 and a negative 4. Sure. Yes, so now from here, if I combine like terms on the left-hand side, 12 plus 22 minus 26 should land you at positive 8. Hopefully you agree that the b and the c terms this time cancel out. Negative 4 times negative 1 gives me positive 4a. And then to get a all by itself, divide by 4. So a equals positive 2. So final answer then here is that our decomposed into partial fractions is you started out with the 3x squared minus 11x minus 26. And then on the bottom you had x plus 2, x minus 2, and x plus 1. We just found out that a was 2, and we had it over x plus 2. We found out previously that b was negative 3, so we have negative 3 over x minus 2. And then we had our c value, which was 4 over x plus 1. And that is your final answer here. Okay. And then I encourage you to try example 4 just to make sure, like I said, you're tracking with decomposing into partial fractions. And just like on that previous example that I did with you, here technically I am using double signs, so plus a negative. Technically we probably should go ahead and change this to minus a 3, but I really wanted to emphasize, what our terms were. Okay. All right, I hope this helps. Let me know if you need anything. Thanks a lot. Bye.